the X-59 is a quiet supersonic technology being developed by NASA in collaboration with Lockheed Martin. Its purpose is intended to transform commercial air travel so it enables quiet supersonic flight over land. Now, unlike earlier aircraft, like the Concorde, its predecessors were restricted due to loud sonic booms, which were not being accepted by the people on ground. Now, this aircraft, the X-59, is engineered to produce a significantly quieter sonic boom, which we call sonic thump, that can be more accepted and tolerable to those beneath the aircraft. So, this aircraft is approximately 30 meters long. It flies at around 55,000 feet, and it's designed to fly, or rather cruise, at a Mach 1.4. Now, among its objectives, it's to collect community response data that will help authorities like the FAA and ICAO to create new sound-based rules that will enable other supersonic aircraft to fly more easily inland, and especially in the USA. Its first flight is scheduled for 2025, where public response will be gathered afterwards. The X-59, this aircraft, marks a crucial step towards a faster, environmentally responsible air travel.
So the first supersonic flight was on October 14 in 1947 with the Bell X-1 rocket engine-powered aircraft, piloted by Charbel J from the US Air Force, achieving a maximum speed of Mach 1.06. Before the introduction of civil transport supersonic aviation, all supersonic missions were only limited to military purposes with a Mach 2.5 limitation. The first civil supersonic aircraft ever made was the Tupolev Tu-144, originating from the USSR, achieving a speed of Mach 2.2. It took its first flight on December 31 in 1968. The second supersonic transport aircraft was the famous Concorde, which originated in both France and the United Kingdom. It took its first flight in 1969 from the city of Toulouse in France, achieving a speed of Mach 2.06. British Airways and Air France were the only operators of this aircraft. Unfortunately, the Concorde retired in 2003 following the tragic accident of Air France flight 4590.
As for the technology used to build the X-59, a combination of advanced vision system, low-boom technology, and specialized airframe configuration was required. The advanced vision system, known as the external vision system, replaces the traditional flight deck with an electronic window. It integrates three elements: 4K camera, FVS camera, and synthetic vision, all displayed on an ultra-high definition cockpit screen. The system provides a 70-degree vertical by 29-degree horizontal field of view with real-time low-latency image and head-up display. Furthermore, the X-59 incorporates advanced composite materials in its airframe, including graphite and epoxy laminates with a honeycomb core sandwich structure in the nose cone. The materials offer a high strength-to-weight ratio, enhancing aerodynamic performance and guarantee dimensional stability under a variety of load conditions.
The X-59 unique design aims to reduce sonic boom noise, making supersonic flight more feasible over land. The aircraft features delta wing design, which permits the aircraft to generate more lift and stall at higher angle of attack compared to typical commercial aircraft wing design. The X-59 is designed with a pointed, elongated nose. This pointy nose creates an oblique shockwave, which is weaker and may keep the flow supersonic after the shock. A shockwave is a sudden change in pressure. When the aircraft approaches the speed of sound, air compresses at the nose, forming a virtual barrier known as a sound barrier. When the airplane exceeds the speed of sound, the air cannot move out of the way quickly enough, resulting in the formation of a shock wave. In addition to the shock wave that happens at the nose, the engine produces a separate shock wave at its inlet. This occurs because the inlet of the engine is designed to decelerate supersonic airflow to subsonic speeds, making it suitable for the compressor. By mounting the engine on the top of the fuselage, the sonic boom intensity from the shock wave is redirected upward instead of downward toward the ground. The aircraft also incorporates forward canards, which opposes to the aft tail design that exerts downward force on the tail. The canards prevent the aircraft from pitching down. With these design features, the noise produced by the shock waves is no longer considered as a sonic boom. Instead, it's termed a sonic thump with an intensity of 75 decibels or closer.
As for the flight test, the X-59 development began with a flight readiness review, in which a board of independent experts from NASA completed a study of the project team's approach for safety for the staff and the public during ground and the flight test. This was followed by an important structure test and critical inspection that included shaking the airplane to make sure there was no unexpected problems from vibration. Developers then proceeded to fire up the GE jet engine by including a series of tests on the engine when it is running full after burn. Another major check was checking the aircraft wiring to connect flights, computer, electronic system, and other hardware together to be sure there was no concerns about electromagnetic interference. Subsequently, engineers tested the aircraft's ability to maintain a certain speed while flying. This testing phase introduced the use of aluminium bird instead of iron bird. Now, this aluminium bird tests the systems of the aircraft itself, which in case saved money and gave engineers confidence in the design. Finally, in July 2025, the aircraft began low, medium, high, and taxi speed tests, during which engineers and pilots monitored critical systems like steering wheel, braking, stability, and sensor performance.
NASA's X-59 program isn't about creating a new passenger jet. The mission of this program is to gather enough information to remove the 50-year-old ban on supersonic flight over land. So this rule is established by the FAA in 1973 under 14 CFR 91817. With the innovative design of the X-59 and extensive flight testing, overland supersonic flight could be reconsidered, as the aircraft reduces the traditional supersonic boom into a quieter supersonic thump. It makes overland supersonic flight possible.